what's in it, and if we know enough about it. All right, so let's get into headspace gas chromatography. There is that wonderful instrument, the headspace gas chromatograph. Why use it? Well, it is the best method for testing for volatile organic compounds such as alcohol. Now, it can be used to test inorganic and organic compounds. I think a teacher said to me one time, if you can smell it, you can test it using gas chromatography. But headspace gas chromatography is a little bit different than just regular gas chromatography. What's the purpose of gas chromatography? Now, there's one thing you got to do with gas chromatography, and that's the total basis for it, which is separation. Separation of compounds. Separations of molecules. So, blood is tested. It's going to have a number of different compounds in it. What you have to do is be able to separate and identify each one of those. If through the testing process they cannot separate, then it's not good. Testing's no good. And you can't quantitate. So if you can't separate two compounds, the machine is going to read them together and then actually potentially identify both the compounds as one and give you a quantity for ethanol where it could be mixed with another type of compound. And if you separate them, it's going to be much lower than when you get a situation where they're not separated. So separation occurs by boiling. Essentially, for each compound, they each have their own boiling point. You heat each compound high enough or warm enough, and it causes a vapor. And then the vapor is shot through the gas chromatograph. There should be separation that's caused, and that's how you start to determine, is this alcohol? Here's Henry's law, and this is essentially what's used. So, once the vial of blood, and I'll show you this in a moment, comes into the lab, what the lab chemist does is actually takes a small portion of that 10 milliliter vial, usually 1 milliliter, tests that, puts it into another little vial, puts another chemical in there, caps it off, and then puts it into the carousel. The machine heats it up, and what happens is Henry's law. So I'm going to give you the definition: at a constant temperature, the amount of a given gas dissolved in a given type of volume of liquid is directly proportional to the partial pressure of that gas in equilibrium with that liquid. All right, what does that mean? So just think of a bottle of soda. Okay, when you look at a bottle of unopened soda, you can't see the bubbles in it. All right, there's constant pressure that is keeping the gas, the carbon dioxide, at equilibrium, meaning there's an equal amount in the air above to the molecules in the liquid itself, all right? If you let this bottle stay at room temperature, and then you take off the cap, what happens? You see the bubbles. They just come up, right? That's essentially the process of Henry's law. And if you put a balloon over a bottle, the balloon fills with the carbon dioxide because it's all escaping. Essentially, the warmer it gets, the more the carbon dioxide in the liquid wants to escape into the air above it. All right, and that's essentially what's happening with headspace gas chromatography. You're not testing the actual liquid ethanol; you're testing the vapor. You're heating up the molecules in the liquid, so those molecules escape into the gas above. You draw out the gas and you test that gas or the vapor. So here's the device, the internal components. You would inject the gas here, and then there's a gas that pushes it through what's called a column. I'll show you that in a moment. It goes out of the machine. There's a flame ionization detector, which burns it up, and then essentially records at what time it's coming out of the machine and how much of that compound is there. And then it goes to the computer, and the computer produces what's called a chromatogram, and you look at that, and it gives you the numbers and tells you what the compound is. Carrier gas is just briefly, what's used is typically helium or nitrogen. It's inert, so it's not going to interfere with the testing process. All right, so there's the sampling, and I'm going to pass this around, but there's, generally in these laboratories, there's what's called auto pipetting, meaning they're not doing it by hand, but I have a hand pipette here. And essentially what the lab chemist puts the pipette into the vial, takes out a certain amount, it's going to be 1 liter on here, 1 milliliter on here, takes it out, and then puts it into the vial. Now, as you can see, there's 2 actions on this. It's down, and then you got to go further down. So if you're hand pipetting, that could be a good source of error, where they're not putting enough of the blood into it. And there's something called an internal standard, which we'll get into, or the internal standard. And you have these auto pipettes, which essentially, they just push a button, and it just pumps the stuff out, the internal standard. All right, so there are lab protocols that need to be followed. The vial itself has a barcode on it, and that's going to be used to identify when it's being tested. So as I said, there's going to be this whole run of a whole bunch of samples, which are called unknowns. You don't know what's in the sample. They're called unknowns. They're all given, the vials all have barcodes on it, and that's typed into the computer, and then each little vial is placed into a part of the carousel, given a number, typed in the computer, and correlated to the actual barcode. Here, sorry, kind of hard to see, but here's the vial. Here is the auto pipetter, and it's just connected to a internal standard, and it's going right into the blood sample. The lab chemist is just pushing a button. Something that you should know that's important: cleaning. Look at the standard operating procedures for the laboratories, their protocols. How often are they cleaning their vials? Obviously, they should do it if they're not disposing them. They should have a method of cleaning each vial that's used. Otherwise, there's going to be remnants of somebody else's blood in there. Pipettes, the same thing. Volume. So, as I mentioned to you before, you're usually taking 1 milliliter of blood, and it's called an aliquot. All right, so it's just a volume of blood. If you're taking more than 1 milliliter, you're ruining the entire process. If you're taking less than 1 milliliter, you're ruining the entire process. It has to be precise, 1 milliliter. And the same for the internal standard. There has to be a particular amount of internal standard. So as I was saying, here are these little vials that are capped. They have a septum on top of it, and a needle goes down, takes out the headspace, the vapor, sucks it into the machine. There are, this whole thing can be filled, hundreds of vials. As long as it's typed in the machine to the computer properly, there shouldn't be a problem. And you see how the numbers correlate to each vial. All right, so there's something called an injector, and that's, as I showed you before, the vapor gets injected into the machine. It's a place for the introduction of the sample, and it's at this boiling point, all right? Here's the port, goes right into there, and the carrier gas comes in at the same time, pushing the sample through the machine. You can see that there's this rubber septum, and below, once you lift it up, there's a glass sleeve that the vapor goes into, what's called an O-ring on top of that. And then this glass sleeve, an injector cap, and septum, they all have to be cleaned. So there can be contamination in that process. Well, when I was explaining this to another attorney, he said something interesting to me, which stuck with me, which is you have to make sure there's no carryover or contamination from somebody else's blood sample, because you don't want another guy's booze in your client's blood sample, essentially is what he said. And that's the case. After a while, these get dirty. And vapor gets, there's contaminants that get stuck to it, and that can carry over into subsequent tests. There's a way to prevent that and make sure it doesn't happen, but...
Are they supposed to document when they do that so you can find out whether they did it properly?
They sure are. And that's what you're asking for. How often are they maintaining, cleaning these components? The same with this gold seal, which is at the bottom of the injection. All right, so there's this column. So the vapor goes in, carrier gas pushes it around the column. And here's a column. It's a very thin, long wire that's wrapped around inside of the what's called the other. Okay, and that's heated.